Hello, my dear students. Now we are in the last and fourth part of this engineering materials topic, in which we will study the mathematical terms for the mechanical properties of the material. So let's start with the first topic, which is known as stress. So what is stress? It is defined as an internal resisting force which is generated inside the material when it is subjected to an external load. So, whenever a material is subjected to an external load, that load can be any types. So, that material with means there is a internal resisting force which is required to withstand at that load without any fracture, without any failure, to restrict the deformation of the material. That internal resisting force is known as stress. So it is mathematically, it is the ratio of the force to the cross section area. So remember this is a cross section area if the force is perpendicular to the cross section. So and it is denoted by sigma, that is equals to force upon area. The unit of this stress is force upon area, means Newton per meter square, and it is a vector quantity because it is directly proportional to the force. So we have mentioned this load, means there are different type of load. So mainly there is three types of loads. First is known as force, second is known as bending moment, or bending, simply you can say bending, or we can say moment, and third is torsion or torque. So we can see in the force section there is a material which is under a pulling force or tension force. So if we apply only this left side force, and we are not going to apply this force, this material will not sustain any stress inside the material because it will just translate in the leftward direction. So it will not exhibit any stress inside the material. Means there is, if we increase this force only leftward force, and there is no rightward force in the with the same amount. So if we increase the value of this force, there is no stress generated inside the material. This material will never fail, never get failed, never get fractured, because it will just move in the leftward direction because the only force is there. So if we want to generate in stress inside the material, we should apply the forces in opposite direction with the same magnitude. So but this is tensile force, pulling, tension, and this is for the pushing or compression forces. So in both the cases the forces will be same, then stress will be generated same, but in this stress will be tensile, and here it will be compressive stress will be generated. So this is the kind of forces. This is the load which is known as force. The second is bending. So we can see if there is a beam beam which is under a load which is responsible for the bending of this beam. So the stress generated because of this bending is known as the bending stresses, and this is also a type of vertical beam, or this is known as a column. Okay, so this is known as column. If the force is applying in the axial direction, this due to instability of the beam or column, it will buckled, it will tilted down. So there will be stresses generated at this layer and at this layer. So this is known as bending or moment applied on the member or machine component or any civil structures. Okay, so the next is torsion or torque applied on the machine member or component, just like twisting of the moment, twisting of this rod. This is the rectangular rod which is under a torque applied. So if twisting force is applied on the machine member or material, so it will causes a restriction of deformation, and restriction of deformation is responsible for the stress generation. So stress will be only generated if there is a restriction. So material itself will opposes its deformation, and its deformation, this opposition of deformation is called the stress generation. So now I'm going to show what is the cross section area for the force, for the load which is known as force. So in that case, what is the cross section area? This is the cross section area. We can see in this image that if this is the member and we apply the forces, forces in this direction, this force is applying on this direction and this force is applying in this direction, though then the material will inside the material, the if we divide this portion will restricted to deform because of the stresses generated inside the material in the rightward direction. But if we see these forces, it is trying to stretch out in the right direction, so stress will generate in the opposite direction to overcome these forces, to restrict the deformation of the material. So the stresses will generate in this cross section area. So in this cross section area, what is the value of this area? If the length is L and the height is B and the width is H, so the area is B into H. This is the area, this is the cross section area. So this cross section area is perpendicular to these forces. So we will apply, put the value of area, which is cross section. So what is area? It is L into H. Is it L into B or it is B into H? It will be B into H only. Okay, only this is the area, cross section area in this case. So next is strain. What is strain? Strain is defined as the ratio of change in dimension to the original dimension. Okay, it is the ratio of change in dimension to the original dimension. So in this case, in the previous case, if we apply the forces in this direction, so which dimension is will be increases, which dimension will be changed? This length dimension will be changed. If we are going to assume that these dimensions are very less in compared with the this length dimension, so there is a very less changes in the B into H, but length will change with a certain value. So only strain will be shown in the L direction, this L direction. So it is defined as the ratio of change in dimension. This change in dimension, we can change in length to the original length. We can put original change in width to the original width. It can be change in height to the original height. So dimension can be anything, but dimension, if we are taking here height, so then we have to take this height here, original height. So the mathematically strain is defined as, and it is denoted by epsilon. This is known as epsilon. So it is mathematically it is defined as change in dimension divided by original dimension. If we are going to use length here, so we have to use length also here. Since it is the ratio of the dimensions, therefore it is unitless quantity. It is unitless quantity. It is a vector quantity because it is change in length, means a certain direction. The change in length is in certain direction, so it is a vector quantity. So we are going to see what is strain here. So this is the material which is under a load in the leftward direction and with equal load in the right direction and length direction, which is responsible for the change in length of the material. So we can see the length is increased. So initial length is LO and final length is LF. Original length is LO, final length is LF. So what is the strain here? The strain is change in length to the original length, because we are going to consider the strain in the L direction only. So it is change in length is the distance between these. Okay, so what is the distance between these is LF minus LO. This is total LF minus LO is delta L. This is delta L. This is delta L. So it is strain equals to delta L upon L original. So this is the formula for the strain. Next is Hooke's law. This is very important law for the relation of stress and strain. So it is states that when a material is under a load, then the stress generated inside the material is directly proportional to the strain generated. Means according to the Hooke's law, stress is directly proportional to strain. So it will equals to sigma equals to E into epsilon, where E is the proportionality constant. Okay, so where E is proportionality constant, E is also known as Young's modulus. It is also known as Young's modulus, and we have to remember this equation very importantly. And E is also known as modulus of elasticity. It is a proportionality constant. Unit of Young's modulus is, which since the it is unitless, and this is Newton per meter square, so this is also Newton per meter square. And Newton per meter square is also known as, we have already done uh, in the case of, we have done in this subject like IC engine also. And Newton per meter square is also known as Pascal. It is the measure of elasticity, means, so it is, there is a elasticity, there is a mistake in spelling, elasticity. So the what is the what is the meaning of measure of elasticity? Means if the value of Young's modulus of any material is more than another material, so we can say that that material is more elastic. And but what is the elasticity? We have already seen in the previous parts that if material will regain its shape and size, uh, then it is known as more elastic then. Or we can say if material is restrict its change in the shape, or restrict the deformation of the material, so that material is known as more elastic. So this relation can be written as Young's modulus equals to stress upon strain. So it is the ratio of stress and strain. So now we are going to see what is the change in length formula. It is a very simple. So we can see the same diagram. So it is original length, and it is the final length, and change in length is delta L when the force is applied. The force is applying here at F also, and here also F. So the stress is F upon A, and the strain is delta L upon LO. So since E equals to sigma upon epsilon, this is the Hooke's law. This is Hooke's law. So from this formula, we are going to put this sigma value equals to F upon A, and this is delta L upon LO, because strain is change in length upon original length. So delta L equals to, from this equation, we will have FLO upon AE. This formula is very important, because if I'm going to give you the numerical value, then numerical formula, like if 5 meter length bar is going under 50 Newton 50 Newton of force, and Young's modulus is something like 200 gigapascal, and the diameter of that rod is 20 mm. So find the total change in length due to this load. So you can find from putting the values of all the given datas, and you can find the value of change in length. Now I'm going to give a very interesting question. Like, just I'm giving there is a specimen of rubber and steel, and the dimensions of both the material are same. In the means length is also same, width is also same, height is also same, and the force applied on this body is also same. So I'm going to ask you a question: which is more elastic, rubber or steel? Means if both are under same value of tension force, having same dimensions, so what will be your answers for this question? So if you are thinking about this, so I'm just also giving the some a hint for this question to solve, and you can give your answer on Google Classroom or YouTube channel comment box. Okay, so I'm giving you a hint that value of Young's modulus will give you the answer. So will you find this the Young's modulus for the both material in this condition? So if you find, then if you not find, if you attempted, if you have doubts, you can ask anywhere. You can ask at Google Classroom. You can ask at comment box of YouTube channel. So thank you for this topic, engineering materials and its properties. So thank you.